Hi, so I'm Lauren, and I'm a software engineer at Microsoft. And so today we're going to talk about software orchestration, and specifically this SDV software orchestration blueprint. Please introduce yourselves as well.
Yeah, hi, I'm Holger from Elektrobit, and I'm representing Ankaios here, and I also participated in the software orchestration blueprint here.
Thank you. Hi everybody, also from my side. I'm a senior software engineer at RedHat and tech lead at BlueG.
And I'm Ibrahim, working at ETAS and responsible for OTA updates, end-to-end solution, and I participated at that as well.
And then we also have a few other people listed here who helped us out as well. So we're going to talk about these topics, software orchestration in general and the workstream group, our new blueprint, then the roadmap ahead for the blueprint, and closing and Q&A. So to kick us off, I'll pass to Holger.
Okay, so I want to start with what the software orchestration work group is about. So actually the kickoff was in February this year, so it's not that old. And the goal we've defined is to define one concrete software architecture that can be implemented on an in-vehicle computer which supports the use cases described below. So first we started, okay, when we talk about software orchestration, what are we going to do? What are the use cases for an in-vehicle computer? So it's not about the cloud. There we know software orchestration very well, but it should run in the vehicle. And for that reason, we define some use cases, which you can see here. So the first use case we've defined is actually deploy and manage non-safety critical applications. So it's about deploying, scheduling, managing, and running multi-container artifact applications in the vehicle. So that was the very first use case we want to start with it. And the second one is actually so deploying also mixed critical safety applications components to multiple targets. So usually in a vehicle we have applications of QM and ASB, and we want to automate the deployment of an application that consists of both multiple artifacts and install them, run them on a containerized platform, on dedicated platforms and controllers. So that's the second use case. And the third one is actually to dynamically deploy application components to multiple targets. And the last one is download and install application to multiple targets, where the targets consists not only of a homogeneous kind, but also in a typical EE architecture in the vehicle, we have different kind of ECUs. We have embedded ECUs, we have HPCs, and we have AUTOSAR update and configuration management, so a lot of standards. And the last one is also to cover those use cases. And then we defined, okay, what do we talk about? So what is it about? And so we said, okay, software orchestration and resource scheduling refers to a set of software components that work together to support deployment and management of in-vehicle resources. So it's all about deployment. I think that's one of the complex tasks we have in a vehicle. So we have so many components that might work in isolation, but when it comes together and managing them, configuration and updating those, that's really a challenging task. The second one, these in-vehicle resources consist of one or more software components that need to be installed and managed in the target and in-vehicle runtime environment. And then we talk about single node, multi-node software orchestration. That means that we are being able to run the containerized workloads on multiple SOCs, both virtual and physical, obviously. And we have one API to manage them all. And the last one is actually multi-domain software orchestration. That means we have, for example, ECUs with Linux, with AUTOSAR, and RTOS, and things like that. And that would be defined as multi-domain software orchestration.
Thank you. So now I'll talk a little bit more about our blueprint. And specifically, the purpose of this blueprint is to showcase a close to real world example of software orchestration in the vehicle with some connections to the cloud. It also allows for vehicle abstractions, which simplify and enhance the development process for vehicle application developers through the workloads that we provide in the blueprint. And through this collaboration, we hope to also explore how software orchestrators, and specifically how applications, can leverage software orchestrators to help tackle some advanced scenarios like resilience, workload placement, and scheduling for their applications. And so these are our initial project contributors, and this was taken from the SDV project landscape page. So on orchestration and management, we have Ankaios, Bluchi, and Canto for our software orchestrators. Then for communication middleware, we have Chariot, which is a service discovery system. We have Agamo, which is a dynamic topic management system for messaging. And on the digital twin side, we have Ibeji, which is an in-vehicle digital twin service, and Freya, which is digital twin cloud synchronization. And so these are our initial project contributors, but we welcome anyone else who'd like to collaborate as well. So now to our use case. Imagine I'm planning to go on travel and I need to carry additional cargo. I connect my cargo trailer to my vehicle, and I'm off to enjoy a fun week at Eclipse SDV Community Days at EclipseCon. Now, this is not my personal use case because I had to cross the ocean to get here, but maybe this could apply to some of you. So in this case, the system detects that a smart trailer is being connected to the car. A signal is raised to the orchestrator that a smart trailer provider and application need to be started up, and they're required to manage the smart trailer, and for example, adjust body functions and powertrain accordingly to ensure a smooth trip to EclipseCon. This is an example scenario that you can build on top of the stack and architecture that we'll show in the blueprint. So for technical details, we have a few technical diagrams that I'll go over, and then Ibrahim will show some more later. For the development environment, we really want to make it simple for anyone who wants to run the blueprint, as well as build use cases on top of it. So we'll be providing a dev container. We'll have Bluchi running as a container, Ankaios as well, and the instructions for how to run with both of those. We'll also have Chariot, Ibeji, Freya, and Agamo available as OCI containers and or systemd processes. We want to offer the flexibility of how you run the workloads. And then some sample workloads, so those would be some applications specific to your use case, like the smart trailer use case I described. And for system requirements, we don't plan on having any hardware dependencies or requirements for running the blueprint. Now, as I mentioned, this blueprint will provide an ESDV stack as an example of an in-vehicle architecture, including our software orchestrators. So as we can see here, we have a number of workloads, and these workloads could be containers, they could be processes. And the blue are the sample workloads I mentioned, or custom applications that are specific to your use case, whereas everything else can kind of stay constant across use cases. With, of course, we always welcome other components to be added to the stack. So if we start in the top left, we have our smart trailer app. And this application will consume one or more signals from our trailer. And in a simple case, could consume something like a weight property, and then display to the user that a smart trailer has been attached with this weight. That could be expanded to, as I mentioned, something like adjusting the powertrain. This smart trailer app will register itself with our service registry and discovery, that's Chariot. And in fact, most of these components also register themselves with Chariot, and it can be used to discover the other applications where they're running so that you can leverage those capabilities. Now, in order for the smart trailer app to consume those signals, we have a couple other applications that help us out. So the dynamic topic management system, which is Agamo, along with an MQTT broker, or any messaging broker, but in this case we're talking about an MQTT broker. And Agamo allows for dynamic messaging topic management. So, for example, if you want to say, I want to receive this signal at a certain frequency, you can do that with Agamo. And that could be beneficial for saving resources, for example. Then Agamo is integrated with the in-vehicle digital twin, which for us is Project Ibeji. And through those two services, you'll be able to find the subscription information for the signals that you're interested in. And a little bit more about that, you would start with a digital twin vehicle model. We use digital twin definition language, or DTDL, for that. And that is just your digital representation of the signals and actuators in your vehicle. And this can be a generic model that could be used across vehicles as well. And then we have what we call the digital twin provider, and that provider exposes one or more of those signals to higher levels of the stack. And so we would use that in conjunction with those other components to get, for example, the weight property of our trailer back to the application. Finally, if you want to synchronize these signals up to a cloud digital twin, for example, for analytics, you can do that through digital twin cloud synchronization or Project Freya. And then up at the top, we have our artifacts repository, which is just an example of where those custom workloads would be coming from. In a simple case, could be a folder in a GitHub repository, or in the case of containers, could be a container registry. And finally, we have our software orchestrator across the bottom. In this case, the example is Encaios. So we have the agent and server from Encaios. And as I mentioned before, once the trailer is connected, a signal would be raised to the orchestrator, or a component that communicates with the orchestrator, to say, now we need to start up these new workloads. Would you like to add anything? No. Okay. So our next diagram looks relatively unchanged. That's on purpose. Now we have blue cheese, server, agent, and system D. And one of the ideas of this use case is to make it so that the workloads don't necessarily need to care about which orchestrator you're using, and maybe just some configuration needs to change. So that's something that we hope to accomplish. Similarly, this is a stack that then you can just replace those custom workloads and implement whatever use case you want to on top of it. And finally, another goal of this is to show the community and help collaborate on how applications can leverage the functionalities of software orchestrators to make more robust applications. Would you like to add anything for Bluechy? Okay, we'll pass it off to Ibrahim to talk about our roadmap. Thank you.
So as you can see, we have defined 3 phases. Phase 1 would be the orchestration of workloads in one or multiple nodes, but with the same technology and stack, like container world. Yeah. So this is what we will focus on in November as well in the hackathon. But phase 2, we want to extend this to multiple domains in the vehicle. So updating or deploying software and managing software in software-defined vehicles means also classic AutoSAR, adaptive AutoSAR, for example. And I will show that in the next slide. And phase 3 would be involving also the cloud world to see how we can extend this blueprint towards the cloud world. So if you look at this picture now, you will see different types of so-called update agents, which we have defined for the different types of domains. And in the middle, you see this so-called vehicle update manager. This is a vehicle-wide software orchestrator, which gets a desired state from the cloud. And we developed this desired state approach into Canto. And it's available there to have a kind of declarative approach for the full vehicle, not only for the container world. And this vehicle update manager would then decide, based on the content of this desired state and the comparison to the current state of the vehicle, which domains need to be updated, and would then provide this information to the respective update agents. And the idea is that they use the same API. So that means all of those update agents get the same API to interact with the vehicle update manager, but they implement specific, in this case, left side APIs towards the domains they need to update. So we have on top adaptive AUTOSAR. In the middle, we have classic AUTOSAR, and we could also have other domains if needed. And this is not only 1 or 2 ECUs, it's usually up to 50, 60, 80 ECUs which need to be updated. And all of this orchestration would be then done by this vehicle update manager in collaboration with the container update agent, UCMM update agent for adaptive or firmware update agent for the classic ECUs. And for example, here would be a UDS communication or diagnostics over IP. And here we would have a some IP-based communication towards adaptive AUTOSAR. And this vehicle update manager and the self-update agent here you see, as well as the container update agent, this is similar to these two Ankaios and Ibeji projects we have seen, but the self-update is available in the LEDA project, and it uses Rauk for Linux-based updates. And for these two update agents, we don't have an open source implementation yet. I think we need to discuss it then together, if and how we could provide this. And this would be the second phase. And if you go to the third phase, in the vehicle side, no changes. So that means this is similar to the previous slide, but on the cloud side, we would then now look at this phase of how do we generate desired states, based on which triggers and which inputs do we generate desired states, and how do we assign them to the vehicles. And therefore, you would need some inputs, like a feature store. That means which features are available and which artifacts are needed to implement and realize these features in the vehicle. So that means you need a feature store, you need a fleet management system, you need an artifact repository, and of course this digital twin is needed to compare the current and desired state and calculate maybe a new desired state for the vehicle. Usually this would also be validated before it's assigned to a vehicle. Of course we have, if you look at the classic domains, also safety requirements, and we have some validation requirements, we have some regulations which need to be checked, and only when this is validated, the cloud should assign the new desired state to the vehicle so that it can be applied to the vehicle. This would be phase 3. And this is something we would define together with you, how this cloud-based approach would look like. So currently there is no project available for this cloud world. We have a specification in Canto for this desired state, how it should be generated and how it would look like for different domains, and this can be extended for different types of workload orchestrators, but for the cloud side, this part of open source projects is yet missing. But this is the idea how we believe it could look like, and we are happy to discuss it with you for the next phases. So I think we are now coming to the closing part. Would you like to take over again?
Yeah, just to close out, I'll reiterate the purpose of the blueprint, which is to showcase a close to real-world example of software orchestration in the vehicle with some connections to the cloud. And it allows for vehicle abstractions which simplify and enhance the development process for vehicle application developers. We want to send a thank you to the entire everyone who's participated in the software orchestration workstream. There's been a lot of people who have brought a lot of great collaborations there, and everyone else who's contributed to the work so far. Thank you. And then questions.
Really cool, super complex use case, lots of projects, that's really nice. And tomorrow, maybe we can continue the discussion. So tomorrow during the open collaboration time, there will be a track on software orchestration. Maybe if you have ideas or want to collaborate, that would be the good time to be there. Any questions so far? Sure.
Thanks a lot for the presentation. I have 2 questions more to confirm. So did I get it right that you actually do 2 blueprints, like one implementing the same architecture with Bluekey and another one with Ankaios, or is there like an overlap between the 2?
No, that's the idea, is to have kind of like 2 implementations, one using one, the other using the other, but within the same blueprint, and give you the instructions on how to run it with each.
Makes sense. And the other thing I was wondering, in slide 13, there was like an overview of all the different agents. I'm not sure if you exactly. So the blueprint that you were talking about is mostly happening in the container orchestration runtime. So, or is there a plan to have some other domains involved?
The blueprint shown in the previous slides, yes, because this is the phase 1, and the focus there is for the containerized world.
Okay.
The idea here is that this is phase 2 next year, to prepare this so that we can extend this blueprint next year for the multi-domains in the car, and then later at also the cloud side. But for this year, end of this year, November, the focus is in the container world, yes.
Okay. Thanks.
Which I should mention what he mentioned in November. We have a hackathon challenge at the SDB hackathon that is to hack on top of this blueprint. So stay tuned.
Maybe a quick personal comment. So regarding phase 2 and phase 3, would be happy to get in touch with you, as we have a lot of experience and do some stuff here. So maybe we can have a quick talk afterwards.
Yeah.
Would be too much for now, you know.
Are you here tomorrow?
Yes, as well.
Yeah, because we have this open session there from 11 to 1. I think exactly there we can also discuss some more details.
Yeah.
But yeah, let's talk afterwards.
So first, sorry, I'm a German, so I also do harsh questions. And my question is, do you really want to make the functional safety engineers to commit to suicide?
So can you elaborate a little bit more?
So you have dynamic configurations in a car. You put a trailer on. So how do you ensure freedom from interference and all those nasty things?
So maybe, if it's okay, I try to answer this. So if you look at the next slide, sorry, the 13, I think it's the cloud next. It should be next. Yeah. So you see, before the cloud gateway sends this desired state to the vehicle, there needs to be a validation of this desired state. And the validation includes, of course, also safety-related validations, tests, releases. And so that means this dynamic part, what you say, if it's only in the QM domain, of course you can do that, but whenever the safety world comes into play, then of course you need to consider these checks. And of course these processes are not automated today. You have many manual work and non-digitized processes, and this is quite abstracting from that in this example. But the hope is that someday we can improve also there these processes with regulations as well. But we don't want to commit somebody to suicide. Yeah, that's right.
Okay, thanks.
Yeah, so maybe a point from my side. So the scope of the blueprints is to see how can we patch the projects together. So, I mean, the use case is a guide for how we do it, but yeah, it's not the solution to a problem. Good. Any other question? No questions. Number 1, 2, and 3. So thanks a lot.